Hey guys, Mr. Backerberg here. In this video, we're going to look at concavity. Now, as we're talking about concavity, the graph of a differentiable function y equals f of x is concave up on an open interval I if the derivative of that function is increasing on that interval I. And we can also say that a graph is concave down on an open interval if the derivative is decreasing on the interval I. So visually, what that's going to look like. So on the left-hand side here, we have a graph that is concave up, and its derivative is increasing. On the right-hand side, we have a graph that is concave down because its derivative is decreasing. Now, to test for concavity, we're actually going to look at the second derivative. So if a function y equals f of x has a second derivative, then we can say that the function is concave up on any interval where the second derivative is positive. And we can say that our function is concave down on any interval where the second derivative is negative. So in this example, we're going to look at using the concavity test to determine the concavity of the given function on the given interval. So we're looking at the function y equals x squared on the interval from 3 to 10. So the concavity test, we need to find the second derivative. So if we do one derivative using the power rule on this x squared, then that's 2x. But then if we do another derivative of that, we get just 2. Now we're looking on the interval from 3 to 10, so we're looking to see where this function would be positive and where this function would be negative on that interval. And because we're just getting 2 is always a positive number. There really is no x for us to plug any numbers into. So this second derivative is always positive, meaning that our graph is going to be concave up, not only on this interval, but on every interval for this function. Now taking a look at this one, we've got the function y equals 3 plus the sine of x, and we're looking on the interval from 0 to 2 pi. Well, if we do one derivative with this function, the 3 differentiates into 0, the sine of x differentiates into the cosine of x, so that's our first derivative. If we do another derivative, cosine of x derives into negative sine of x. Now we're checking to see where this second derivative would be positive and where it would be negative. Now there are going to be some places where our derivative is going to change signs. So what I want to do first is figure out where this second derivative is going to equal 0. So I'm going to take negative sine of x and I'm going to set that equal to 0. We could divide both sides by -1, so then we just get the sine of x equals 0. And then to get x alone, we would really have to do an inverse sine. So we're doing the inverse sine of 0, which means that we're looking on our unit circle, because we're looking between 0 and 2 pi, we're looking for angles where the sine, where the y value, would be 0. And that's going to happen 3 times as we make one trip around our unit circle. That's going to happen at the x value of 0. That's going to happen at the x value of pi, and that's also going to happen at the x value of 2 pi. Now what I'm going to do with these is draw out a sine chart. Now on this end, we've just got 0. On the right end, we've got 2 pi, because we're just looking between 0 and 2 pi. And then in the middle, we've got pi. So we really want to look at what's happening to the left of pi and to the right of pi for those intervals. So I want to pick some test values that fall on each one of these intervals to then plug into my second derivative to figure out what's happening. So between 0 and pi, I'm going to pick pi over 2. So I'm going to plug that into this negative sine of x. So doing the sine of pi over 2, we'd get 1, but then we would have to attach a negative to that, so then we'd get -1. And again, the answer itself doesn't really matter. It's just the sign. So this is going to be a negative interval from 0 to pi, but then something between pi and 2 pi, maybe we pick 3 pi over 2. Well, the sine of 3 pi over 2 is -1, but if we attach another negative to that, the double negative is going to turn that into +1. So this is going to be a positive interval on the right-hand side. So between 0 and pi, where we have this negative interval, we can say that our graph would be concave down. And then on the right, where we have this positive interval, we would say that our graph would be concave up between pi and 2 pi. That's going to be it for this video. Thanks for watching.